Hello, this question is asking us to figure out how to count up the number of ways winners or places can be selected. So when you have a total group of things and you're picking out of them, this is what we consider a counting problem, which is important for probability to count the number of ways something could happen. So there's three main types: combination, permutation, and fundamental principle of counting. Combination and permutation are often grouped together because they are similar in that when you're making those decisions, everything is being pulled from one group. So whether you're picking 2, 3, or 4 things, all those things or people are coming from the same group of those. What you do afterwards turns that into a combination or a permutation. Combination, the order in which those things are chosen does not matter, whereas a permutation, once you choose those 4 things, for example, you then do something with them. You arrange, place, or order them, those particular people, which increases the number of ways that that can happen. Versus a fundamental principle of counting is where each of those things you're choosing come from a completely separate sample space, or like a repeated sample space, meaning like sets of numbers that you can use over and over, or sets of letters you can use over and over again, where a combination and permutation, once you've chosen something, it's chosen, you can't choose it again. So let's look at our problems. We have a radio station. It's got 82 finalists trying to win 2 trips to the concert of their choice. There's a grand prize and a second place prize. Okay, so that phrasing right there means there's a first place, grand prize, and a second place prize. So there are differences between first and second. And everybody's coming out of those 82, which is why this is considered a permutation. Right, so I'm going to put a big P here because the order in which they're selected matters. If we look at question part B, 12 students are running for the positions of president, vice president, and secretary on the student council. How many different ways can the positions be filled? Again, the president and vice president and secretary are all different positions, so they're unique about them, and that's where we have these positions, or assigning names, maybe even ranking could be considered as to why that is also a permutation, so I'll put another big P here. When you're doing permutation or combinations, we have a separate notation where it's kind of like NPR, where the N represents the total number of things you're choosing from. R is how many you are choosing. There's some formulas with factorials and things like that where you could do this, by hand, or at least, in a more complex way, slightly more complex. We're just going to go straight to the calculator. So this first scenario, we have 82P. We're picking 2. Right, so you're picking 2 different places. So on my calculator, I just go straight to math. Depending on your calculator, you might need to hit 82 first and then hit math. Either way, you're going to go to probability. And you see number 2, it says NPR. That's what we're looking for, not NCR. That'd be a combination. So we're going to pick NPR. So I'm going to put 82 first. And then you see my calculator actually gives it that kind of nice notation. If not, 82, then NPR2. You hit enter, so that means that there are 6,642 different ways these winners could be chosen out of those 82. And then if you have the second one here, you have 12P3 different positions: president, vice president, secretary. That's 3 different positions. So go back to math, probability, NPR. I'm going to put 12 first, and then after that I put a 3. And I hit enter, so that means that there are 1,320 ways that those positions could be chosen. Right? And so this is just counting up all the possible ways something could be done, and it's kind of interesting because we end up with some kind of surprising results on